Okay, we're now recording. And I'll share the screen. All right, so I'll begin with the list that I had yesterday. And I'm not promising I can get to all of them, but we'll give it the old college try, as you say. Okay, so we're just doing a review day. If the questions stop, I might just continue on to chapter 4. I don't think that's going to happen. It seems like there's enough problems for me to go on. And I'm aiming for quantity more than quality. I want everybody to see the question once. I'd rather, a poor job is better than no job at all, right? So if you're left hanging on, let's say, section 3.10, number 7, it's better if I show you something than if I don't show you at all, right? Okay, and you can always go back in the video and review it later on. So test tomorrow. We're off for a week. Then we start up again on Monday, April the 5th. I've already snuck in a little bit of 4.1, so that'll just help me when we get to that, okay? All right, so if you want to put stuff in the chat, you may, but I'm mostly going to ignore the chat until I go back and try to address all the problems from yesterday as much as possible, starting with 3.5. Okay, and for a lot of the stuff, I'm going to end up saying etc. If I can get you to a point where I think you can do the rest because quote unquote easy algebra, then you can go from there. Okay, and I'll go section by section. So I'm up to 3.5. Okay, so the default is if I don't put a section number, it's the same as the previous problem. Okay, so 3.5. This is 3.5. 3.5. Number 5, x squared. I think it's easier if you think of it as plus negative 4xy plus y squared equals 4. Okay, students will sometimes get confused if you leave it in negative, because then you may forget to count it as part of the product group. So it's easier to think of it as plus this, and this is the first function, second function. Okay, implicit differentiation, 2x plus negative 4x dy dx, product root, plus second times the derivative of the first, plus 2y dy dx, and that's equal to 0. Okay, so all the dy dx stay on one side, the others go on the other, so that goes over, that goes over. These two have a dy dx, factor out the dy dx. 2y minus 4x, and these two come over and change signs, so it'll be positive 4y minus 2x, divided by this, so dy dx equals 4y minus 2x over 2y minus 4x. You could factor out a 2, and then reduce. I'll let you do that. That's fairly straightforward. Okay, 7 x to the 4th plus x squared y squared plus y cubed equals 5. Unfortunately, I can't see the book from the distance that I'm at. Okay, so this is x squared y squared. Okay, so product rule here, 4x cubed plus x squared times 2y dy dx plus y squared times 2x plus 3y squared dy dx equals 0. I do have to watch the time because I want to make sure I do at least some problems from every section. Okay, everything that does not have a dy dx goes over. So that goes over, that goes over. These two have a dy dx. So keep them on the left side and factor out the dy dx. 2x squared y plus 3y squared. And that'll become a negative, and that'll become a negative. Negative 4x cubed minus 2xy squared. Divide both sides by that. Dy dx is negative 4x cubed minus 2xy squared all over 2x squared y plus 3y squared. Okay, so that's that. And let's see. I'm going to do 21 because it's a different kind of a problem. f of x plus x squared f of x cubed equals 10. F of 1 equals 2. Find f prime of 1. Okay, differentiate both sides. F prime of x plus product root. First times derivative second, 3 f of x squared times f prime of x plus second f of x cubed times derivative of the first, 2x equals derivative of the right side is 0. Okay, and plug in 1 everywhere. Put a 1 there and 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 a 1 there. So I have f prime of 1 equals 1 squared times 3 times f of 1, which is 2 squared, f prime of 1 plus f of 1 cubed, it's 2 cubed, times 2 times 1 equals 0. Okay, so let's see, that is 3 to, this is 12. This is 16. So f prime of 1 plus 12 f prime of 1 plus 16 equals 0. 1 plus 12 is 13. 13 f prime of 1 plus 16 equals 0. So f prime of 1 is negative 16 over 13. Okay. All right, that's as much as I feel like doing right now for 3.5. Okay, I realized there were more questions in 3.5, but I want to make sure I give time to doing some of every section at least. So 3.6, I still have it in my list. 3.6, 21, 23, 19. 3.6, 19. Y equals ln. And trouble again is I can't see it unless I raise up the book, which is heavy. E to the negative x plus x e to the negative x. Okay, and then not only that, I got these wires that, so I just might end up tangling myself up here. Okay, so before you start, what you want to do is factor out the e to the x. Oops. E to the negative x, 1 plus x. This is ln of a product, ln of something times something is ln of the first plus ln of the second. And ln of e to the negative x is just negative x. Now it's easy. Derivative is negative 1 plus 1 over 1 plus x. Okay, so that's that. 21. Y equals tangent ln ax plus b. So chain root, chain root, chain root. Derivative tangent of something is secant squared of that. Okay, so I'm done with that. Now I differentiate ln of something. So it's 1 over ax plus b times derivative of ax plus b, which is a. Okay, 23. Y equals radical x ln x. Remember, this is like x to the 1/2. So y prime is first times derivative of the second plus second times derivative of the first, 1/2 x to the negative 1/2. Okay, that's x to the 1/2 divided by x to the 1. That's x to the negative 1/2 plus 1/2 x to the negative 1/2 ln x, which I think is easier if you factor out the x at a negative a half. 1 plus 1/2 ln x, and then put that into the denominator as 1 plus 1/2 ln x over radical x. I don't like the half there, so before I take the second derivative, multiply top and bottom by 2, make it look nicer. 2 plus ln x over 2 radical x, which I'll treat as 1/2 2 plus ln x over radical x. Okay, so for the second derivative, I've written as 1/2 times a function. So the derivative is 1/2 times the derivative of the function. Okay, so I differentiate this bottom times derivative of the top plus top times derivative of the bottom over that. And the rest is algebra. So I'll just say etc. and leave that alone. Okay. 3.8. To turn the paper over. So let me do my focusing job here quickly. So that. All right. Okay, I'm up to 3.8 now. .85 was asked for. There are lots of parts to it, so I'm going to just pick and choose what I want. I will just pick part A, 1750, 1800, and 1900. That's all I'm going to do. Okay, to save time. So A, 1750, the original population was 790. Okay, so 5A, I'll just say 5A first. So P of T is P0, 790, e to the KT. Okay, and then use the data from 1800. 1800 means 50 years. So 980 equals 790 e to the K times 50. Okay, that's the difference between 1750 and 1800. Okay, so divide by 790, divide 790. 98 over 79 equals e to the 50K. ln 98 over 79 equals 50K. Divide by 50. Okay, so ln 98 over 79. ln 98 divided by 79. Divide the answer by 50. 0.00431. So my equation becomes P of T equals 790 e to the 0.00431 T. T is time since 1750. Okay, the base year is 1750. And now they ask for 1900. So the calendar year 1900 from 1750 means the time is 150. So I plug in 150 right here. P of 150 is 790 e to the 0.00431 times 150 equals whatever. Okay, 790 e to the 150 times the answer, 1508. And these are millions, or you can say 1.5 billion. Okay, it says compare with the actual. Actual was 1.6 billion from the chart. Okay, so that looks pretty close. And all the other questions in problem 5 are just like that. So that's that type of problem. Okay, 11. Okay, carbon 14 has a half-life of 5,730 years. C14, half-life of 57, 30 years. Okay, discovery revealed a parchment that had 74% carbon-14 as material today. Estimate the age of the parchment. Okay. So 74% of original. Okay, so A of t is A0 e to the kt. Half-life 0.5 A0. That's half the original. E to the k 5730. Divide by A0, divide by A0, cancel, cancel. Take the natural log of both sides. ln here, ln here. I have to go back up. ln 0.5 equals e to the 5730k. ln cancels out here. So k is ln 0.5 over 5730. Squiggly equal. ln 0.5 divided by 5730. So negative 0.000121. On my calculator, it has in scientific notation, negative 1.1209 times 10 to the negative 4 means that. Okay, so A of t is A0 e to the negative 0.000121 t. Okay, and now it says we have 74% of the original. So 0.74 A0, that's 74% of the original. No problem. Is equal to A0 e to the negative 0.000121 t. Basically doing the same stuff. Divide by A0, divide by A0, gone, 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 gone. 0.74 equals e to the negative 0.000121 t. ln, ln, cancel, cancel. ln 0.74, negative 0.000121 t. Divide both sides by this, negative 0.000121, negative 0.000121. And t is approximately so many years. So ln 0.74 divided by 2489 years. So that'll be roughly what, 500 BC for that one. Okay, and let's see, 19 was also asked for. What time is it? 9:30. Okay, 19 is the same thing except we're doing with altitude and pressure. The rate of change of atmospheric pressure is proportional to P. Okay, so the initial pressure at sea level is 101.3 kilopascals. Okay, and then it gets smaller as the altitude goes up. Okay, so P of T is P0 e to the k. This time it's not time, but it's height or altitude. Okay, the starting was 101.3. Altitude at sea level, the pressure is 101.3 e to the kh. Okay, now we're given at 1,000 meters, it's only 87.14. So 87.14 goes here, 101.3 e to the k h. Divide by 101.3, divide 101.3. 87.14 over 101.3 equals e to the 1,000 k. ln, ln cancels out. ln 87.14 divided by 101.3 is equal to 1,000 k. Divide by 1,000, divide by 1,000. Punch it in the machine. ln parentheses 87.14 divided by 101.3. Divide that by 1000. Negative 0.000150. Okay, again, the calculator might give it to you in scientific notation. The e minus 4 means times 10 to the negative 4, or move back 4 spaces. So that's it. So P of t is 101.3, e to the negative 0.001506h. All right. Okay, what's the pressure at top altitude of 3,000 meters? Plug in 3,000. Part B, 6187. Let me just plug in B, Mount McKinley. So P of 6187 is 101.3, e to negative 0.001506 times 6187, which is approximately so many kilopascals. Okay, so let me just do that. 101.3, second function, e to the parentheses, answer times 6187, 39.90. Okay, for part A, same thing, just plug in whatever they tell me, 3,000. All right, the problem's finished and I'm done with that. I'm moving on, but I'll just mention quickly for those of you that want to do mountain climbing and so on. So what's the atmospheric pressure at sea level is about 100. If you're on top of Mount McKinley, Mount Denali, it's 40, less than half. So it's obviously much harder to breathe up there because there's less air. Something you have to consider if you do heavy duty mountain climbing. Okay, so that's it for 3.8, 3.9. What time is it? 9:35. And I haven't tackled all the new questions that are there. Okay, 27 and 23. See what I want to do with that. 27, I don't believe was assigned. 3.9, somebody asked for 27, that wasn't assigned, so I'm skipping that. 3.923. Okay, so ship A is 100 kilometers west of ship B. A, B, sorry, because of the fastness of which I'm going, I'm not even getting my ruler for this. This is 100 kilometers. A is going south, 35 kilometers per hour. B is going north, 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? So that's 4 hours. Okay, so here's my picture. What I'll call this X, I'll call this Y. I'll complete the picture like so. This is 100. This is also Y. All right, 35 kilometers per hour, 4 hours means 140 kilometers. 25 kilometers per hour times 4 hours is 100 kilometers. Call this Z. So how fast is the rate of the distance changing between the two ships? That's dz dt. So Pythagorean relation, x plus y squared plus 100 squared equals z squared. Okay, I can find z by the Pythagorean theorem. This is 140 plus 100. So 240 squared plus 100 squared equals z squared. Okay, I will save time and just tell you that it comes out to be 260. This is a variation of a 5, 12, 13 triangle, if any of you have heard of that. But otherwise, just take my word for it for now. This is 260. So X is 140, Y is 100, Z is 260, dx dt is 35, dy dt is 25. Okay, differentiate with respect to time. 2 times x plus y to the first power times derivative of the inside, which is dx dt plus dy dt plus derivative of 100 squared root of 0 equals 2z dz dt. Divide both sides by 2z, 2z, cancel, cancel, cancel. dz dt is x plus y over z, dx dt plus dy dt. And my answer is kilometers per hour, kilometers per hour. And now it's just a plug-in. So let's see, x was 140, y was 100, z is 260, dx dt is 35, dy dt is 25, and you can take the rest of that. Okay, 3.1025. Cube root of 1001. So f of x is cube root of x, or x to the 1/3. And the nice nearby number is 1,000. 1,000 comma 10. Cube root of 1,000 is 10. F prime of x is 1/3 x to the negative 2/3, which is 1/3 x to the 2/3. Plug in 1,000. F prime of 1,000 equals 1/3 1,000 to the 2/3. 1,000 to the 2/3 means cube root of 1,000, which is 10. Square it, it's 100. 100 times 3 is 300. So 1/300. So y minus y1, y minus 10 equals m times x minus 1,000. So my L of x is 1/300x. This is a little bit clumsy. Minus, let's see, 10/3 plus 10 30/3, which is 20/3. Okay, so 1/300x plus 20/3. Okay, so to approximate the cube root of 1,001, have L of 1,001 is 1/300 times 1,001 plus 20/3, which is whatever. Yeah, I'll go ahead and do that. 1,001 divided by 300 plus 20 divided by 3. 10.0033. 10.003 repeating, essentially. And just for fun, actually took the cube root, 10.003332228. So you can see it's pretty close. Okay, that's that. 3.1113. Okay, I'm done with this. So let me quickly show you this again. And I think I'm done with everything from yesterday, except for a few extra ones. Then I'll check the chat for more stuff. Okay, again, take advantage of Prasanna's notes that he has and get some extra help from him if you wish to. Okay, so that's that. New sheet of paper, what was it again? 3.1113. Cos squared equals 1 minus hyperbolic cosecant Okay, so this is cos over sinh. So that's e to the x plus e to the negative x over e to the x minus e to the negative x squared. 1 minus. Okay, so hyperbolic cosecant is a reciprocal of sinh. 2 over e to the x plus, whoops, minus e to the negative x quantity squared. So let me work on this side. This is going to be minus 4 over e to the x minus e to the negative x quantity squared. So to get a common denominator, let me put the same thing here. E to the x minus e to the negative x squared, e to the x minus e to the negative x quantity squared. Okay, and I can see what's going to happen here. This has a common denominator. So let me work out the top. The top comes out to be e to the 2x minus 2ab, 2 times that is just going to be 2 plus e to the minus 2x. Let me check something here. The minus 1 should be here. Sorry, I read it wrong. Okay, I botched this up. Minus 1. Well, looks like I'm gonna have to just start all over. Cos squared x minus 1 equals, okay. Okay, so this was okay. E to the x plus e to the negative x. What time is it? E to the x minus e to the negative x squared. Okay, so it's hyperbolic cos over hyperbolic sinh. The 2's will cancel out, so you have that minus 1 equals 2 over e to the x minus e to the negative x quantity squared, which is 4 over e to the x minus e to the negative x quantity squared. Let me try to get the curl out of the paper. Okay, so this is e to the 2x plus 2ab, 2 times that times that. That times that is 1. 2 times that is 2, plus e to the negative 2x over e to the x minus e to the negative x quantity squared, minus 1, which can be written in the form of e to the x minus e to the negative x squared over e to the x minus e to the negative x quantity squared. Okay, so I do have a common denominator. Okay, I don't have to work on this side anymore, so I'm crossing over here, so to speak. E to the x minus e to the negative x quantity squared. So e to the 2x plus 2 plus e to the negative 2x minus e to the 2x minus 2 plus e to the negative 2x. Okay, if I square that, e to the 2x minus 2ab, 2 times that is minus 2. Okay, cancel, 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 cancel. 2 minus a negative 2 is 4. So 4 over e to the x minus e to negative x quantity squared, and they are now equal. Okay. All right, so I think I've finished everything from yesterday with a couple of exceptions. Okay, I'll try to show you this again, which was 3.1113. Skip that part there that I messed up. We have about 10 minutes left. So, okay, so now bear with me as I try to catch anything else that's in the chat. So, and the hard part is to tell whether I've already done one of these. Okay, 3.81119 did that. Dominique, I got you. 3.93, 937, 3.10, 921, 25, I think I already did. 3.11, 735, I've already done 13. 3.57, I did. 3.7. Hard part, of course, it takes 5 minutes just to write all this down and to double check whether I've already done it. 3.57, I did not do, intentionally because of time. And of course, when you're going 100 miles an hour like this, it's very easy to miss something. I may have double count something or I may miss something. That's the way it goes. I did not do 17, so that's still on tap. 15, 3.6, 43, 51. 3.613. Somebody's here. Okay, somebody's 3.5, number 5. Why does such happen? Okay, I'm not sure I can answer that quickly. Plus, it may take me a long time to find out where that problem is now. So, why do we set equal? Okay, I hope that was answered. The right hand, maybe I think the right hand side was a constant, therefore it became 0. So I think that's what's going on there. 3.554. Okay, let's see, Prasanna has a note. There's a 4 to 5 review session today. Thank you, Prasanna. Anybody else? Let's see, 3.937. 3.515. Okay, so I think I've caught up. I'm almost sure I can't do all of them. So I'll have to pick and choose what I want to do in the remaining precious few moments that we have. Let's see, 3.515. 3.515. E to the x over y equals x minus y. Let me e to the x, y to the negative 1. I think it's easier that way. X minus y. This is implicit differentiation, so e to the x, y to the negative 1 times the derivative of x, y to the negative 1. First times the derivative of the second, negative y to the negative 2, dy dx, plus y to the negative 1 times 1 equals 1 minus dy dx. Okay, distribute, and put that in a denominator. It'll be negative that thing. So negative e to the x over y squared dy dx. Distribute that. It'll be that divided by y e to the x over y divided by y equals 1 minus dy dx. Put the dy dx's together, so move that one over there, move that over there. Factor out the dy dx. This will be a positive 1 minus e to the x over y divided by y squared, assuming I didn't make a mistake here, equals 1 minus e to the x over y divided by y, and divide both sides by that. So dy dx is 1 minus e to the x over y divided by 1 minus e to the x over y divided by y squared. It's usually not a good idea to leave an answer like that. So multiply top and bottom by y squared, make it look nicer. So y squared minus y e to the x over y divided by y squared minus e to the x over y. Okay, so that's what I have for that one. Okay, kind of have to pick and choose here. 3.613. Yeah, that one you definitely want to use your property of logs. G of y is natural log 2y plus 5 squared over radical y squared plus 1. ln of a quotient is ln of the top minus ln of the bottom. And bring the 2 in front and the half in front. So 2 ln 2y plus 5 minus 1/2 ln y squared plus 1. In case you're wondering, you cannot simplify ln of a sum. So don't try to distribute the ln here, just leave it alone. Okay, so g prime of y is 2 times 1 over 2y plus 5 times 2 plus 1/2 times 1 over y squared plus 1 times 2y, cancel, and etc. Etc. is 2 times 2 is 4, put it there. Sneak that over there, but I'll leave you to do that so I can have more time to do other stuff. Okay, got to pick and choose here. 3.5, 3.554. 3.554. Y equals inverse tangent x minus x squared So to differentiate inverse tangent, you go 1 over 1 plus this thing squared. Then by the chain root times the derivative of this, which is 1 minus 1/2, 1 minus x squared to the negative 1/2 times negative 2x. And I'll just have to say et cetera after that. You can cancel that with that. You can probably do a lot more. I'm guessing a lot of this comes out very nice, but in the interest of time, we'll just leave it like that for now. Okay. And let's see, what else am I willing to do? Last couple of minutes, 3.1135. So I need to say one word about the test again, even though it's mostly repetition. 3.1135. Okay. 3.1135. Sinh of LNT. Chain root. Derivative of sinh is cosh. times the derivative of ln t, which is 1 over t. And then just slide this underneath. So cos ln t over t. Okay, 7. Show that sinh of negative x equals negative sinh x. Okay, sinh of negative x is e to the negative x minus e to the negative x all over 2, which is e to the negative x minus e to the x over 2. This is the opposite of the definition of sinh, is e to the x minus e to the negative x divided by 2. Take the opposite of this, you just switch these around. E to the negative x minus e to the x divided by 2. And that's about it for that. Okay. All right. And because of time, I will have to stop and I can't do any more problems. I will just blab quickly about the test again. So sorry, I can't do any more. Unless you want to catch me during office hours, or you can always ask Prasanna. Okay, so once class is over today, you can start sending in the homework. Tomorrow, no question and answer, we'll go straight to the test. Around 9:02, 9:03, 9:04, something like that, I'll send to Canvas announcements, the exam. You start right away. I won't call the roll, but I'll take attendance. I got plenty of time to do attendance. And you have until our usual stopping time is 10 o'clock. So you have until 10:05, take a picture on your cell phone and submit it to me. And you have until 10:30 to submit the homework. But if you want to send it in early, you can start sending in once class is over today. And there's a 70% homework requirement. You must submit at least 70% of the homework. Otherwise, I do not grade your test. The 70% is really easy to do since we end up doing, I dare I say, sometimes we end up doing 70% of the homework, including everything we did today. That shouldn't be that big a deal. So let's see, your camera's on, true background, right? Keep yourself muted. If you have a question, put it in the chat. And I think that's pretty much about it. Let's see, what else did I miss about the test? You've seen the test before, but it's been a long time. Okay, and that's it. Then everybody have a nice spring break, and we meet again on what, Monday, April the something. April the 5th. And I've already stuck in a little bit of 4.1, so that'll help in that circumstance. Okay. All right, and let's see what else. Yeah, if anybody joined late, go ahead and put it in the chat. I'll check it a little bit later, but otherwise that time seems to be up right now. All right, so that's it for today, folks. So have a good day, and we'll see everybody for tomorrow at the test. All right. Okay. Bye, everybody.
Hi, I just have a quick question. Are your office hours right now or are they later today?
10 to 11.
Okay, that's what I thought. And then it's in the syllabus, right?
It's in the syllabus also.
Okay.
Yeah.
I will see you then. Thank you.
All right. See you. Okay. Bye.